Have you ever really thought about how a mountain gets that pointy peak? Or, how a huge, flat plain even gets there in the first place? Well, today we are digging into the incredible story that's written all over the face of our planet, the major landforms of the Earth. If you could just zoom out and look at our planet, you'd see its surface is anything but boring and uniform. It's this absolutely breathtaking canvas of giant, towering peaks, massive flatlands, and literally everything in between. These are Earth's landforms. Some are rugged and kind of imposing, others are gentle and just sprawl for miles. And that really brings us to the big question, right? Why? Why isn't our planet just a perfectly smooth ball? What kind of powerful forces are out there sculpting all this incredible variety? Well, to answer that, we've got to look at the planet's own sculptors. It turns out that every single landform, from the tiniest hill to the mightiest mountain range, is basically the result of two processes that are always competing with each other. Okay, think of it like a constant cosmic tug of war. In one corner, you've got the internal process. This is like the Earth's construction crew. These are forces deep inside the planet that are always pushing the land up, building mountains and plateaus. But in the other corner, you have the external process. This is nature's sculpting crew. Things like water, wind, and ice that are relentlessly wearing that same land down through erosion and then rebuilding it somewhere else. So, let's see how this epic battle actually plays out. We're going to start with the most dramatic results of that internal upward push, the true giants of our world, mountains. So what even makes a mountain a mountain? Well, generally speaking, it's a natural rise in the Earth's surface that's got a pretty small top, or summit, a really wide bottom, or base, and it has to be way higher than the area around it. We're usually talking over 600 meters. But here's the thing. Not all mountains are created equal. Geologists actually group them into three main buckets based on how they were made: fold, block, and volcanic mountains. First up, we've got fold mountains, and honestly, the best way to get how these form is to imagine taking a big stack of paper and just pushing it from both sides. You see how it buckles and crunches up into a peak? That is exactly what happens when two of the Earth's tectonic plates smash into each other. This process creates these massive ranges like the Himalayas and the Alps, which are actually some of the world's youngest and most rugged mountains. Next up are block mountains. Now, these are created when huge areas of the Earth's crust literally crack and then shift up or down. The blocks that get pushed up are called horsts. Those become the mountains. And the blocks that drop down are called graben, and those form the valleys. A perfect example of this is the Rhine Valley over in Europe. And third, we have volcanic mountains. I mean, the name pretty much gives it away, right? These are formed by volcanic activity. You get all this molten rock, or magma, building up under enormous pressure. It erupts, and then it cools in layers of ash and lava, which slowly builds up a classic cone-shaped mountain. You've definitely heard of famous ones like Mount Kilimanjaro in Africa and Mount Fujiyama in Japan. But hold on, here's a fact that'll blow your mind. The tallest mountain on Earth, it's not Mount Everest, no way. It's actually Mauna Kea in Hawaii. So what's the catch? Well, most of it is hidden underwater. It's an undersea mountain, and if you measure it from its real base on the ocean floor all the way to its peak, it stands at a jaw-dropping 10,205 meters. That just completely dwarfs Everest. So, okay, mountains are majestic and all, but why do they matter so much to us? Well, for one, they are gigantic storehouses of fresh water, all locked away in glaciers that feed so many of our great rivers. And that water is absolutely vital for everything from farming to generating electricity. There are also these incredible hotspots for all kinds of plants and animals. And of course, they are amazing playgrounds for tourism and adventure sports. Okay, let's move on from the pointy peaks of mountains to our next big landform, the huge elevated flatlands that we call plateaus. So what in the world is a plateau? Honestly, the best way to picture it is as a giant flat-topped table that's standing high above all the land around it. Yeah, you can see it perfectly here, those characteristic steep sides and then that pretty flat top. Plateaus can be super ancient, like the Deccan Plateau in India, or they can be incredibly high, like the Tibet Plateau, which is actually the highest and largest one in the whole world. And plateaus are incredibly useful to us. They're like these natural treasure chests, just packed with mineral deposits like gold, diamonds, and iron. That's why so many of the world's biggest mining areas are located on them. They can also create some spectacular waterfalls, and in the case of lava plateaus, they leave behind this amazingly fertile black soil that's just perfect for farming.
All right, so from the highlands, let's make our way down to our third and final major landform, the vast and fertile lowlands that we all call plains. A plain is, well, it's pretty much exactly what it sounds like. A huge stretch of flat land. They're usually pretty low-lying, not more than about 200 meters above sea level, and they can be either perfectly flat or just kind of gently rolling.
So, where do these huge flat areas even come from? Well, believe it or not, most of them are actually built by rivers. As rivers come rushing down from the mountains, they're carrying a ton of eroded stuff, sand, silt, you name it. Then, over thousands and thousands of years, they just deposit all that material downstream, slowly building up these vast, flat, and incredibly fertile areas.
So we've covered mountains, plateaus, and plains. But what does all of this actually mean for us? Well, this brings us to the most important part of the story, how these landforms directly shape our lives.
And the difference in how we live on these landforms is just, it's night and day. Life up in the mountains is often really tough. The climate is harsh, and there's very little flat land to grow food. But plains, they offer pretty much perfect conditions. The flatland is great for building houses, for cultivating crops, for creating transport networks. So it's really no surprise that plains are the most densely populated places on the planet, while mountains are pretty sparsely populated. And that really brings us to our final thought. Those internal and external forces we talked about at the very beginning, they never, ever stop. The Himalayas are actually still rising, and rivers are still carving out new valleys as we speak. Our planet is alive, and it's constantly changing. So it kind of leaves us with this one last big question. What will these very same landforms look like in a million years?